Hello, Mr. Myesis here, and today I'm going to talk about, in this video, I'm going to talk about solving a system of three equations with three variables. Now, in this problem, we're going to look at a system, and I want you to keep in mind a few things. One, make sure you try to get two equations with two variables, or we want to at least eliminate one of the variables in our beginning. A lot of times what students do is they sometimes try to eliminate variables, but they try to eliminate different variables at different times, various steps, and they get all confused and jumbled. And if you just take it step by step and choose one variable, z, x, whichever one, y, doesn't matter. Y doesn't matter. Choose one of the variables, x, y, or z, and eliminate that one and stick to that one. Eliminate that first, and then use that to solve the rest of them. So we're going to keep that in mind, and then again, take your time. If you take your time through this, you're less likely to make any errors, and that's what really gets students is when they make an error algebraically, it really messes up the whole thing, and these problems can be very long and tedious. So you want to make sure you take your time and do it right the first time. So what we're going to do here is we're going to take a look at this problem, and I want to make sure that, one, you take your time, and you're going to look at maybe using a combination of elimination and substitution methods. So let's take a look at this one. We have solved the system, x minus 2y plus z equals 15, 2x plus 3y minus 3z equals 1, and 4x plus 10y minus 5z equals negative 3. So the first thing we have to do is choose a variable to eliminate. It really doesn't matter which one, just choose one. In this case, I think I'll choose z. Z seems to be one that I can get. So what I'm going to do with that is I'm going to take one equation, maybe this one, and use the other two equations to eliminate that one variable. So let's use these two equations first, the top two, and we're going to eliminate z. So in order to eliminate z, I'm going to want this one right here to be a 3z, so that when I add these two together, this z's will be gone. So I'm going to multiply this equation by 3. What I like to do to keep organized here is I'll write my new equation just right next to it. So I'm going to have 3x. I'm going to distribute this 3 among this entire equation, minus 6y plus 3z equals 45. I'm going to write this equation, since I'm not really going to touch it, I'm not going to change it at all. I'm just going to write it right underneath and copy it over. 2x plus 3y minus 3z equals 1. And then we're going to add straight down to use elimination. So we're going to get 5x minus 3y equals 46. All right, so we got rid of z once. Now we're going to need to get rid of z again by using the other equation. It's still the top one, but we're going to use the bottom one now, okay? So in general, that's kind of the rule you want to use. If we use the top one and the second one, then use the top one and the last one. It's easier to work with that way. So in order for me to eliminate the z using the bottom one, I'm going to need to multiply by 5, so that 5z and negative 5z cancel out. So now I'm going to multiply by 5. And I'm just going to write it right underneath. It'll be easier because then I don't have to rewrite the last one. So I'm going to have 5x minus 10y plus 5z equal to 45. So now that I have it written down here, I can use elimination and add the two lines together, the two equations together. Get 9x. Wow, look at that. Actually, my y's cancel out too. And my z's. Well, that's very helpful. And I'm going to get 42. I feel like I did something wrong. This is not 45. This is 75. There we go. 72. Okay, 5 times 15, 75. So now, all I have to do here is divide by 9, and then I have my x. So that's great. So if I divide 9 in both sides here, I'm going to get x equals 8. Wow, look at that. I got my x. So now that I have my x, I don't really want to plug 8 back in either of these because I'm still going to have the problem with having y and z. So, but I did, however, get this to have two unknowns in this one. So I'm going to go and plug my 8 here, and that will allow me to find y. So let's do that. I'm going to have 5 times 8 minus 3y equals 46. And now I can solve for y. 46. Subtract 40 from both sides. Positive 6. And then divide by negative 3. And then get y equals negative 2. All right, so we're almost there. We've got x and we've got y. Now all we have to do is find z. And what we can do is we have x and y. We can plug those back into any of these three to find z. I think I'll choose the first one because I don't have to do anything with the z here in terms of dividing. So let's go ahead and do that. So I'm going to use the first one here, and x is 8. So I'm going to have 8 minus 2 times y, which was negative 2, plus z equal to 15. Okay, now we're just going to simplify this and solve for z. So I'm going to have 8, I'm going to have a negative 2, and negative 2 is a positive 4, so 8 plus 4 is 12. And I'm going to subtract 12 from both sides here. And my answer is going to be 3. So I get 8, negative 2, and 3. And sometimes teachers ask you to put this in an ordered triple. So you're going to write it as 8, comma, negative 2, comma, 3. And that'll be your final answer. So again, just to wrap up, make sure you take your time. Your very, very first thing you're going to do is make sure that you eliminate one variable and one variable only. Then you can move over, eliminate another variable and solve for that one. Then start to plug things back in step by step. So you're going to plug things back in here to find y, plug it back in here to find z. Use both x, y when you found those previously. All right, thanks for tuning in. If you got any more questions or you have some other subjects that you want to ask, just type them in the comments and I'll try to put up a video for that. Thanks for hanging out. Bye.